In this lesson, we'll talk about the find command. Now that we tried out querying collections using the Atlas UI, let's see if we can do the same by connecting to our cluster from the shell. Let's connect to the Atlas cluster and see how that works. Notice that the database that I'm connecting to is called admin. If the database is not specified, the default value here will be test. Admin is the default database that does a number of administrative things, one of which is keeping track of existing users that have access to the database. Now that we are connected, it's time to start querying the data. First, let's make sure that all the databases are here and we're connected to the right cluster. ShowDB shows the list of databases that are in the cluster. You can see the additional admin database that I already mentioned, as well as the local database, which is another default database that takes care of administrative stuff. We will not touch these two in this course. The rest look exactly like the databases that we saw in Data Explorer, so that's good news. Time to select our database of choice. We want to reproduce what we tried in Data Explorer in the previous lesson. So let's work with the sample training dataset. To indicate that we will now be working with the sample training database, we issue the use sample training command. To view the collections in this database, we issue the show collections command. And here they are, all the collections that we saw in the UI. To query the zips collection, we issue a find command, which works like this. We don't have to specify the database name since we navigated to the needed database earlier, and now the DB object is pointing to the sample training database. So the syntax is db dot collection name dot find, and the query goes inside the parentheses. If we were to count all the documents that are displayed here, we would find that we're looking at exactly 20 documents. But as we know from earlier exploration in the Atlas UI, there are more documents in the collection that match this query. To view the next 20 documents with state New York, type it, which stands for iterate. This command allows us to iterate through the cursor, which is an object that the find command returns. Formally, a cursor is a pointer to the result set of a query. And just to make sure that we're all on the same page, a pointer is a direct address to the memory location. I'm now really curious to know how many zip codes are there in New York State. By the way, for those of you who are unfamiliar with the United States address format, a zip code is what is known as a postal code in the rest of the world. To find how many zip codes there are in New York, I can add a count operation at the end of my find command, like this. Now I know what the Atlas UI meant by many when we looked up all the New York State zip codes. In that case, many meant exactly 1,596. What about the documents that are in New York but also in the city of Albany? Will the count still be 7? Let's find out. We added the city is Albany criteria to the query and kept the count option in place. And the result is indeed 7. So far, so good. The only thing that concerns me now is being able to view this data in a nice, more readable way. Let's do just that. Currently, running the find command on this query yields a very busy looking result. I want to be able to see the structure of each document, and preferably each field value pair should be placed on a separate line. To achieve that, we can use the pretty directive. Let's see how it works. Perfect! This data is now much prettier to look at and easier to read as a result. Finally, if you issue the find command without a query, like so, the first 20 documents of the collection will present themselves to you. But the documents are not organized in any particular order, so they can be any 20 documents from the collection. These are the basics of querying a collection with MongoDB. In this lesson, we talked about how to navigate your data from the Mongo shell. After you connect to your Atlas cluster, you can then start navigating your data and running queries. The environment in which you do that is called the Mongo shell. For the developers among us, Mongo shell is also a fully functioning JavaScript interpreter. We used showDBs, useDBName, and show collections to view the namespaces available to us. We then queried the data using the find command, which returned a cursor with documents that matched our query. Finally, we learned to find out how many documents match a given query using count, and how to view documents in the cursor in a nicer, more readable way using pretty. All examples used in the lesson can be found in the lecture notes below the video.